All right, y'all, we're back to finish up this worksheet. We're looking at questions 10 and 11. Or if you're just looking at this from the future, using it as a study resource, then you might not have this worksheet in front of you, but it's still a great couple of questions to look in on. So number 10 asks us to determine whether the first system of equations is equivalent to the second system of equations when we need to justify or explain our answer. What you need to know about equivalent systems is that if two systems of equations are equivalent, what that means is they have the same exact x and y as a solution. So you're looking at these two systems and you say, well, these two lines intersect at a place and these other two lines intersect at the exact same place. So you have potentially 4 different lines all intersecting at the same x and y value. But that's not always going to be the case. And let me show you what I mean. If we look at our two systems here, and we look at specifically the coefficients for x and the coefficients for y, our coefficients for x here are 3 and 2. And our coefficients for y here are 5 and -6. Let's compare the coefficients for x and y in this first equation in our first system to the first equation in our second system. In the second system, you see the coefficients are, I'll use different colors here. I'll use red and orange maybe. (18) and 30. Right? Maybe something else we note is that our sum here in this equation is 1, and our sum here in this equation is 6. So there's something that we can tell right away by looking at the first equation in the first system and the first equation in the second system. How do we get from, let me choose a unique color here to help us out. Maybe I'll choose this blue here. How do we get from 3 to 18? Oh, that's not helpful. Let me make that a little bolder for us. How do we get from 3 to 18? We multiply by 6. And we see that pattern kind of follows, right? 5 to 30, that's multiplying by 6. And 1 to 6, that's another multiplication by 6. So what's the difference between the first equation in the first system and the first equation in the second system? Well, you just took everything and you multiplied it by 6. And what we saw in those 4 practice problems from the previous video is if we multiply an entire equation by something, that doesn't change its value. It just changes what that equation looks like. So the line for that equation is going to be exactly the same, even if the coefficients for x and y and the sum number are all different, right? Just because they look different doesn't mean they're different in value. So maybe I can write this in a way that's a little easier to see. The only difference between these first equations is to get from the first system to the second, you just multiply by 6. Right? Let's look at the bottom one, see if we can notice a similar thing going on here. From 2x to 10x, that's multiplying by 5. From -6y to -30y, that's also multiplying by 5. And if we go from 38 to 190, that's a bigger number, but 190 divided by 38 still gets you 5. Okay? So what's happening in the second equations is you're just changing how they look by multiplying everything by 5. All right, so what does that tell us? Well, that tells us that these two equations in these two systems, they are equivalent, right? So the systems are equivalent. Right? Now, how do we know? The first equation in system 1 was changed. That's not how you spell that word. Change by a factor of 5. The second by, that's factor of 5. It should be factor of 6. The second by a factor of 5. While the equations look different, they are identical in value. All right? And so that's a lesson for us. Whenever we have these systems of equations, multiplying an entire equation by the same number does not change the value of that equation. All it changes is how it looks. Okay? So these two systems are equivalent because the first equations are identical in value and the second equations are identical in value. What we have here is two of the same lines just kind of being, or two of the same systems just kind of being layered on top of each other. All right? We're going to finish our worksheet off here with number 11, which is a bit of an application problem. So we're going to take this in 3 parts. First, we're going to attempt to model the scenario, and then we're going to think about how we can set it up for elimination. Then we're going to set up, we're actually going to solve for one of the variables, and lastly, we're going to solve for the other variable. All right, so it says the cost of 2 bottles of water and 4 apples is $5.50. The cost of 3 bottles of water and 5 apples is $7.50. We have to find the exact cost of 1 apple and the cost of 1 bottle of water. Whenever you have a word problem like this, the very first thing you're going to do is define your variables. For us, what that looks like here is x and y, because there are 2 unknowns in the problem, right? We need to find the cost of 1 apple. And so I'm going to say that is our x value. So x equals the cost of an apple. And we got to find the cost of 1 bottle of water. That's going to be our y. All right. So we can kind of take what the question's giving us here and use it to model. It says we're buying 4 apples, so 4 apples times whatever an apple costs. And we're buying 2 bottles of water, so 2 times the cost of a bottle of water. And that's going to equal $5.50. All right, remember, our total here usually goes at the end of problems. 4 and 2 we know are our CRCs because that is how many of each of those items were purchased. We do the same thing for the other set of costs. We know 5 apples, so 5x, and 3 bottles of water, 3y, equals $7.50. So then those are going to be our 2 equations that represent the scenario. All right? We're going to take that and we're going to begin to think about how we could set it up to solve with elimination. And what I notice if I'm looking at the coefficients for x, their LCM, their lowest common multiple, is going to be 20. And if I look at the coefficients for y, their LCM is a little bit lower, right? Lowest common multiple between 2 and 3 is 6. So I'm going to decide that we're going to go ahead and set these up for elimination of the y variable. And the way to make that happen is we're going to multiply the top by 3. And because I want to make this setup when we eliminate to add, right? We want to set this up to cancel out with addition. I'm going to multiply the bottom by -2, right? So everything in the top equation gets multiplied by 3. Everything in the bottom equation gets multiplied by -2. We're going to take this to the next box, and we're going to actually do that multiplication. 3 times 4x is going to give us 12x. 3 times 2y is going to get us 6y. And 3 times 550 is going to get us 1650. Down below, negative 2 times 5x is going to get us a negative 10x. Negative 2 times 3y is going to get us a negative 6y. And negative 2 times 750 is going to get us negative 15. And now that we have this set up for elimination, we're just going to add our two equations together. 12 plus negative 10x is going to get us 2x. 6y plus negative 6y is going to cancel out. They eliminate each other. And 16 plus negative 15, or 1650 plus negative 15 is going to get us $1.50. Dividing both sides by 2 to get x by itself is going to leave us with x equals 0.75, which is the same thing as saying 75 cents. Now, because of how we defined our variables, we know x represented the cost of an apple, so we just found that an apple costs 75 cents. All right? We're going to finish this problem off by looking to the other variable, right? We solved for x. Let's go ahead and solve for y. We do exactly the same way we did in the practice problems. We're just going to pick one of our equations. We're going to plug in our newfound x value there. I'm going to choose the first one. I like it a little more. It's got even numbers for coefficients. Just makes me feel a little good. 4x plus 2y equals 550. But we now know that x's value is actually 75 cents. So 4 times 0.75 plus 2y equals 550. And now all we do is simplify, subtract, and divide. 4 times 0.75, 75 cents is going to get us $3 even. Let me not put the decimal there. Now we're just going to subtract 3 from both sides. We end up with 2y equals 250. We're going to finish off just dividing both sides by 2. And so we end up with y equals $1.25. And because of how we defined our variables, we know that y represented the cost of a bottle of water. So a bottle of water costs $1.25. All right, and that's it. We've successfully modeled the problem, set up for elimination, eliminate one of the variables, solve for the other, and then use that value to find the value of the other variable. And that is how you handle elimination. Thanks for listening, guys. Thanks for watching, and I will see you in the next video.